Okay. Well, today we're going to talk about alpha lipoic acid. Um, it's a pretty uh, well-known supplement, but not real well-known. It's I guess I would say well-known in at least a lot of different circles. Um, it's a very interesting one. It's something that our body actually makes, but it doesn't always make it in high enough amounts to be optimal. So even though it's essential for our body, it's not considered an essential nutrient like a vitamin per se, but it is conditionally uh, essential in that there are times when we really do need more of it, and we can get it from diet or supplements, either one. The supplements can be in a number of different forms. They can be liquids or soft gel capsules, tablets, two-piece capsules, potentially powder, although I've never seen it marketed it as a powder, but it could be. Now, what exactly is alpha lipoic acid? And we show you a picture of the molecule over there. And you will notice up here the two uh, gold colored atoms there. Those are sulfur molecules. So it's an interesting product because those sulfurs are where the activity really takes place. Um, it's an important cofactor for critical reactions in energy metabolism. We really can't live without alpha lipoic acid. We just wouldn't be able to produce the energy we need to survive. When glucose is processed for energy, it is broken down to pyruvate, um, or if not pyruvate, then it is shuttled over to make lactic acid and lactate. And that sort of increases in the cells. And you know that when you're doing a lot of really vigorous exercise, the lactate builds up in the muscles, and it can act. That's one of the things that will limit the ability of the muscles to continue performing when there's excess lactate buildup in the muscles. So we don't normally see that in normal everyday activities, but athletes experience that all the time, and it's because the um, pyruvate can't get shuttled through uh, to go to the Krebs cycle and be metabolized completely for energy. However, the muscles were able to make a lot of pyruvate and lactate and produce a little bit of energy, but a lot of it because it just does it so much. So when glucose is processed for energy, it's broken down to pyruvate, like we said, or converted to lactic acid. The pyruvate then is still in the cytosol of the um, cells, muscle cells, or whatever cells in the body. But then it's converted to acetyl CoA, and it goes into the mitochondria of the cells, where really you have the big time energy production occurring. So we see that to really get the energy um, out of the glucose, you really have to have this step with the alpha lipoic acid. Now, alpha lipoic acid can do some amazing things, and we'll get back to more of the basic stuff in a little bit, but it's actually can be used as a treatment for mushroom poisoning. If you look at this mushroom over here, you'll notice that you've probably seen some pretty similar looking mushrooms growing around this area. Um, that's a very dangerous mushroom. It can kill you. So, um, an interesting story though, back in the 1970s, I believe it was, uh, a gentleman who had gotten his PhD in biochemistry, went on to medical school, and as a first year medical student, he was assigned to take care of somebody who was dying from Amanita mushroom poisoning. And it really can destroy the liver and kill a person in a matter of days. It's a very deadly poison. Turns out that when he was working on his PhD, had come across some information that alpha lipoic acid could be beneficial in neutralizing the poisonous effects of the mushroom. So he got in touch with somebody at NIH and asked them to send him some alpha lipoic acid. And they did intravenous infusions of alpha lipoic acid in the person who was dying from the poisoning. And the person survived and healed completely. And turned out that they kept doing it for similar type problems and were able to have 79 people, of 79 people who would have died, 75 of them survived doing that particular therapy. So it had worked very effectively for preventing liver damage on those people, and was a lifesaver. It also has been used a lot for diabetic neuropathy. A lot of people with diabetes have the tingling in the hands and that type of thing, and lose some of the function in their hands, I believe. And this actually seems to be a fairly effective treatment for that. And it's pretty commonly used for that purpose. It's also a very effective antioxidant, but also restores other antioxidants. And it's interesting, it can be soluble both in lipid and aqueous solutions, and that makes it pretty versatile as an antioxidant. Most antioxidants like vitamin C is just soluble in water, and it's found in parts of the body where they can be soluble. And that vitamin E is totally lipid soluble, so you usually find it in cell membranes and things like that, associated with lipids. But alpha lipoic acid can go to either area and be rather versatile. Now, there are several forms of ALA out here. ALA exists as an R or S isomer, stereoisomer, and it's just a slight rearrangement in the molecule. The makeup of them are exactly the same as far as the chemical composition, but it's how the molecule is arranged. Only the R is made in nature. The S form is somewhat effective, but not as much. However, the R isomer is rapidly converted to the mixed isomers, and that's been a problem. A lot of people have tried to market RALA, but if you buy an RALA product, almost for sure by the time you actually get it, it's going to be back to the racemic mixture of the R and S isomers. It's that unstable as the R isomer. Bruce Ames, who's a very prominent researcher, and he actually came here to Kannapolis to speak a few years ago, but he did a lot of research on ALA, and really he had a lot to do with popularizing it as a dietary supplement. He started out with selling RALA, but later just did ALA because of the stability issue. However, in the lab, when he was doing his research, he used the RALA because he was able to make it up freshly and used it, right away. That gives you a little bit of a conundrum. If you're reading his studies where he used RALA in research to get the exact same effect, you're going to have to pretty much double the amount of ALA that you're using, because the isomer does seem to have some benefits. In fact, it's probably pretty good antioxidant still, but for its enzyme activity, it's probably not going to be quite so good. So, you really have to realize that you've got to increase the amount of ALA supplements that you're using if you're going to get the same results from when they did studies using just the RALA. Typically, doses of alpha lipoic acid range in the 200 to 1,000 milligram range, depending on if you're trying to just maintain normal levels, taking it just as a general supplement, or if you're looking for a specific effect, you may want to take more. Generally, you don't want to get too carried away with ALA, and I wouldn't go over the 1,000 milligrams. One thing you have to worry about a little bit is most of these antioxidants are not just antioxidants, they're redox agents. That means that they can be both antioxidant and pro-oxidant sometimes. And if you get high doses, that seems to happen more. So they can have kind of a chain reaction. This vitamin C may be an antioxidant to something else, but then again, that other thing oxidizes or reduces again the vitamin C, and you get a chain reaction going. And that can be detrimental at times. So you can overdo antioxidants. So you've got to be a little bit careful with that. And that's why I'm saying I think I would limit the ALA to 1,000 milligrams. That's plenty, I think, for anybody to use, unless maybe you eat the wrong mushroom. That may be a different story. But it's a very, very beneficial supplement for many people. Now, we were talking a little bit about where ALA works in metabolism, and this will just kind of show you. Glucose, as I told you, is converted, well, first through phosphoenol pyruvate to pyruvate. Okay, and this is all occurring in the outside part of the cell. The acetyl-CoA pyruvate is converted to acetyl-CoA by pyruvate dehydrogenase. So it's made into acetyl-CoA in this pathway. Acetyl-CoA goes into the mitochondria where it becomes metabolized by the Krebs cycle or citric acid cycle, whatever you want to call it. And it's also here again at this stage, the alpha ketoglutarate dehydrogenase enzyme complex here catalyzes this reaction. So it's actually used twice. The alpha lipoic acid is in the production of energy. And this is the basic function, and probably this function right here is what really makes it useful for diabetics, for other people who athletes and people like that who want to utilize this their glucose and blood sugars for making energy, and not for storing them as fat or storing them as blood sugar and glycogen and things like that. You're Now, alpha lipoic acid has a lot of proposed functions. Um, in a study published in Biochemica Biophysica Acta in 2009, that article listed several things. Endogenous antioxidants. There again, it not only is it antioxidant itself, but it regenerates uh, glutathione here, ascorbic acid, also vitamin E, though, and a number of other antioxidants. And the vitamin E is particularly interesting because vitamin E really isn't a redox agent so much. It's what they call a chain breaking antioxidant. It stops it in uh, it stops that chain reaction in its tracks. And it really is a true antioxidant, vitamin E is, under almost all conditions. So that was very important. It's good for the vascular system, production of ENOS, the nitric oxide, uh, production. According to them, it may help lower blood pressure. It helps prevent inflammation. Great for glucose metabolism, as we've already talked about, for stress, and well, I lost my place here, and for metabolism in general. So we see that there's a lot of really great benefits to alpha lipoic acid. It is a key factor in energy metabolism and oxidative uh, stress. So do you really need ALA? Do you need to take that as a supplement? Well, many people do, and especially those with increased metabolic needs. I would say that you know, most athletes, for instance, would certainly benefit from extra ALA, uh, and highly active people, not necessarily professional athletes. It also appears that its ability to help utilize sugar for energy uh, prevents it from being stored as fat, and it's been suggested and used for weight management and weight loss. Also for keeping blood sugar in a normal range. ALA is unusually effective as an antioxidant because of its ability to actually regenerate other antioxidants. It also may be beneficial, and this is where a lot more study needs to be done for a lot of other liver problems. Particularly, I think would be interesting to see more studies on its use protecting the liver against alcoholic and non-alcoholic fatty liver disease. These are big problems, and non-alcoholic fatty liver disease is becoming quite common because of the obesity in the society. That's a real risk factor for the NAFLD, non-alcoholic fatty liver disease. And it's something that's being seen more and more. So I really feel like there's a lot of good reasons why you should take ALA for at least a lot of people. And, we have it available, of course, as 300 milligram, I believe, supplement. And we have it as also part of our Intercell product. So we've got several ways you can get it, at least two, maybe more. But it's a product that I think is well worth taking a look at for many people. And with that, I'll stop here and open it up for discussion. I don't know.